write note කියලා දාලා ලියන්න. note කියලා ලියන්න. On the Cartesian plane, on the Cartesian plane, on the Cartesian plane, on the Cartesian plane, in the Cartesian plane, there are infinitely many, there are infinitely many, there are infinitely many, there are infinitely many straight lines. There are infinitely many straight lines. These straight lines, these straight lines, these straight lines, these straight lines can be divided into two major categories. Can be divided into two major categories. Two main categories. Two main categories. Below that, write Roman number 1. Roman number 1. Straight lines that are parallel to the x-axis or y-axis. Roman number 1. Roman number 1. Straight lines that are parallel to the x-axis or y-axis. Straight lines that are parallel to the x-axis or y-axis. Roman number 2. Straight lines that are not parallel to x-axis or y-axis. Straight lines that are not parallel to x-axis or y-axis. Straight lines that are not parallel to x-axis or y-axis. So that's just a small note. We will be needing that note when we are discussing the other theory parts. Hari, ahangin. If we take a xy coordinates plane, we can have straight line segments which are parallel to the x-axis like this. L1, L2, L3 කියලා දාන්න පුළුවන්. Or we can have straight line segments which are parallel to y-axis. I'll separately draw that. Y-axis, x-axis. Parallel to the y-axis. ඔහොම තියෙන්න පුළුවන්. We'll take it as U1, U2, U3, just names. Just names. This is one category. The other category is the straight lines that are not parallel to the x-axis or y-axis. So randomly aneva. Okay. So this can be L1, L2, L3. So among those, there are some straight line segments which are parallel to each other but not parallel to x-axis or y-axis. So x-axis, y-axis, we have straight lines. These are parallel to each other but not parallel to both x-axis or y-axis. X-axis, y-axis is parallel, but these are parallel to each other. This is a special case. We'll discuss about it. Ek discuss karana tha pay dekak patyai. Alright. So to come to that point. Okay. So this is just a small idea. Separately write definition. Definition. Separately write definition කියලා. Separately write definition. 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 මෙහෙම ලියන්න. You see? Definition. Put a colon and write gradient of a straight line. Gradient of a straight line. ඔන්න ඔතනින් පස්සේ තමා පුතා coordinate geometry උණු වෙන්න පටන් ගන්නෙ. Now the time it's going to get more interesting. Hari. Right. Below that, write the definition, Puda, as a note. Write the definition. The angle made by a straight line segment, the angle, sorry, the angle, sorry, the tan ratio of the angle, the tan ratio of the angle, the tan ratio of the angle, the tan ratio of the angle made by a straight line segment, made by a straight line segment, made by a straight line segment with the positive direction of the x-axis, with the positive direction of the x-axis, with the positive direction of the x-axis is referred to as the gradient of that straight line, is referred to as the gradient of that straight line, is referred to as the gradient of that straight line, is referred to as the gradient of that straight line. Now here see, x-axis, y-axis, we have a straight line. Let's take that straight line is L1 kila namak denna. The angle made by that straight line segment with the positive side of the x-axis, I'll mark the origin as capital O, with the positive side of the x-axis. If I take this angle as theta, and let's take the gradient, usually we name it as simple m, no? If I take the gradient of L1 equals to m kila, just a notation I am giving. This gradient is equals to tan ratio of that theta angle. Tan ratio of that theta angle. 30 degrees now. If the angle is 30 degrees, tan 30 degrees, 1 over square root of 3. So the gradient is 1 over root 3. If this is 45 degrees, gradient is going to be tan 45 degrees. Gradient is 1. Okay. So this is where we define the gradient of a straight line segment properly. ඇත්තට මේක තමයි O level වලත් කරන්නේ පුතා. In O level also we are doing the same thing, but we don't give this definition. But basically we are calculating the tan ratio of the angle implicitly. තේරෙන්නේ නැතුව calculate කරන්න වල tan ratio එක තමයි. How? So let's take a straight line segment like this. Okay. So we have x1 comma y1, මෙතන x2 comma y2. How do we calculate the gradient of a straight line segment in all levels? Difference of y coordinates divided by difference of x coordinates. No, y1 minus y2 divided by x1 minus x2, or y2 minus y1 divided by x2 minus x1. කැමති විදිහක්. So if I take it like this, y2 minus y1 divided by x2 minus x1. Then මං කියනවා this is the tan ratio of this angle. මෙන්න මේ angle එකේ tan ratio කියලා මං කියනවා. කොහොමද? This is x1. This is x2. If I draw straight line segment, what is this? This is x2 minus x1. How do me? y2 minus y1. Tan ratio, tan theta is what puta? Opposite side divided by the adjacent side. y2 minus y1 divided by x2 minus x1. O level වල මෙන්න මේක කියලා දෙන්නේ නැතුව මේක කටපාඩම් කරනවා. අන්තිමට A level එනවා ගොන් සෙට් එක. අපරාධි O level syllabus එක මෙලෝ රහක් නැති syllabus එකක් තියෙන්නේ. Why you have trigonometry in O levels, no? Why they can't put this? Trigonometry තියෙනවනේ. You know how to calculate the tan ratio. Then why the hell they can't put this? ලස්සනට දාලා මේ පොඩි concept එක උගන්වන්න පුළුවන්. උගන්වන්නේ නැහැ. A level අහම අලුත් දේවල් වගේ බලන්න. අලුත් දේවල් නෙවෙයි මේ ඉගෙනගත්තු දේවල්. Just පොඩ්ඩක් elaborate කරලා එච්චරයි. Okay. Right. So don't draw this, just draw this one. We'll discuss this one separately. මේක ආයෙ පාරක් වෙනම discuss කරනවා. Yeah. Below that, put a star mark in red color pen and write. Below that, put a star mark in red color pen and write. Below that, put a star mark in red color pen and write. if a pair of straight line segments, which are not parallel to x-axis or y-axis, below that one put a star mark and write Venamalianna. It's another concept we are discussing. Put a star mark and write in red color pen. If a pair of straight line segments which are not parallel to x-axis or y-axis, if a pair of straight line segments which are not parallel to x-axis or y-axis, are mutually perpendicular to each other, put a comma, then the product of the gradients of those two straight line segments, then the product of the gradients of those two straight line segments, then the product of the gradient of those two straight line segments is -1. Then the product of the gradients of those two straight line segments is -1. Menna mehema ahan indago. We have y-axis, we have x-axis, origin. We take a pair of straight line segments that are not parallel to either x-axis or y-axis. This is L1 straight line, this is L2 straight line. But those are perpendicular to each other. If if I take a pair of straight line segments which are not parallel to x-axis or y-axis, parallel na may situation is not applicable, which are not parallel to x-axis or y-axis, then the product of the gradients of these two straight line segments is going to be -1. If I take the gradient of this one to be m1 and gradient of this one to be m2, so they say that these two are perpendicular, means product, when you multiply the gradient of this one and gradient of this one, answer is -1 කියලා කියන්නේ. මෙන්න මේ idea එකෙන් පුතා ගණන් හදන්න තියෙන 27 A level batch. Remember, when it comes to differentiation and parametric function differentiation වල short questions වල මේක හෙනට තියෙනවා use කරන්න. Okay, 26 A level batch students, they have already done calculations using this in differentiation part. පන්ති මං ගණන් හදලා තියෙන්නේ. So this is a very important discussion. Essay paper එකේ මේක අනිවාර්යෙන් එනවා. Okay, product of two perpendicular straight line segments gradients are -1. M1, M2 multiply karama, product is -1. This application will be there obviously in the exam paper, either in short question or in essay question, or sometimes in දෙකේම තියෙන්නත් පුළුවන්. Okay, අනිවාර්යෙන් හැබැයි තියෙනවා. Okay, චේතුර කලින් ඒව නැද්ද? නෑ අකෝ කලින් ඒව ටිකක් තියෙනවා. හරි. කලින් ඒව ටිකක් අනිවාර්යෙන් අහනවා. But this one something that students don't get sensible quickly වගේ scene එකක් තියෙනවා. In the question you need to apply, but ටක් ගාලා අමතක වෙන part එකක් ඕක. Don't forget, there are many things when it comes to trigonometry and straight lines, especially trigonometry and straight coordinate geometry. Sensitive parts are there, students will quickly forget. ඒක මම කියලාම තමයි I'm discussing trigonometry and coordinate geometry. Don't forget the small detail that we discuss in the class. Everything is important, right? So below that note, quickly draw this diagram. Visualize it. So how do we prove it? Here see, if I'm taking the angle as alpha, if I take this angle as beta, we can clearly see that there is an acute angle, there is an obtuse angle. Right? Then there's an acute angle, there is an obtuse angle. We know the gradient of a straight line segment is the tan ratio of the angle created by the straight line with the positive side of the x-axis. Make a tan alpha. M2 is tan beta. M2 is tan beta. So the tan ratio of an obtuse angle is plus or minus. It's in the second quadrant. Second quadrant sign positive, tan negative. Calculate if it is an obtuse angle in the second quadrant. In second quadrant, if we get a sine ratio of that angle, answer is positive. Cos ratio, tan ratio become a negative. Right. So taking that idea, can you try to take the product of these two and prove that it is -1? Try it. I'll give you like 30 seconds. Idea use trigonometry. Trigonometry, the things that we discussed so far is enough to do this. Okay. Now listen. Stop working and listen. Geometry, O-level geometry, coordinate geometry. Well, let's use O-level geometry. I'll extend this. This beta angle, okay? Puda, listen, na. I'll take this triangle. If this is 90, this is 90. I'm producing this line. This is a horizontal line. I'm producing that horizontal line. This is also a horizontal line. Then I make out smooth beta. We know that according to this according to this triangle, exterior angle is equals to interior sum of the interior opposite angles. So beta is equals to what, Puda? 90 plus alpha. Let's consider the tan ratio of both sides. Tan beta is equals to tan 90 plus alpha. So tan beta is equals to what, Puta? Tan 90 plus alpha is cot alpha, no? Harida. Paradi yako minus cot alpha. It's minus cot alpha. Why? The trigonometry, Buddha. This is in the second quadrant. Second quadrant, tan minus odd multiple of 90. So tan changes to cot alpha. Minus cot alpha means 1 over tan minus 1 over tan alpha, no? So I'll write it here. Tan beta is equals to minus 1 over tan alpha. Do a cross multiplication. Tan alpha times tan beta is equals to minus 1. How the tan alpha? M1. Who's tan beta? M2. This is equals to minus 1. So if two straight line segments are perpendicular to each other, the product of the gradients are going to be product of the gradient is going to be minus 1. Olivia do the proof. 27 batch can't say make a danne trigonometry oy part of line segment parallel to the x-axis. We'll take the straight line segment's name as L1. We'll take the gradient as M1. We know the gradient is equals to tan ratio of the angle made by the straight line with the positive side of the x-axis. What the angle? 0. And a gradient is 0. This is origin. Below that, right again. Consider a straight line segment parallel to the y-axis. Consider a straight line segment parallel to the y-axis. Parallel to y-axis means makes a 90 degrees angle with the x-axis, no? So which is tan ratio of 90 degrees. Numerically taken as infinity, but originally what's the idea? It's undefined. Now can you see? If we take a pair of straight line segment, one is parallel to the x-axis, the other one is parallel to the y-axis, then product ekak infinity, anithaka 0. Product is what? 0. Product is 0. So if there are two straight line segments which are parallel to the x-axis and y-axis now, those two straight line segments are giving the gradient product 0 actually. So we don't get calculations from that. Taking up the calculations in our do. Harne. Write as a subtopic. Lianna subtopic එකක්. Write a subtopic. Write a subtopic. Write a subtopic. Angle between two straight line segments. Write the subtopic. Angle between two straight line segments. 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 Right. Hangin na. I'll take a straight line segment like this and another straight line segment like this. We'll take this straight line segment as L1. I'll take this as L2. Let's take the gradient of this one as M1, gradient of this one as M2. Let's take this angle as theta. Okay. Let's take it as 30 degrees just for calculation purposes. 30 degrees. Then we know that this angle is going to be 150 degrees, no? Why is that? Angles on a straight line, no? All of us. 30 now. Some should be 180, this is 150. Right? So I'm not calculating the gradient here. I'm just considering the tan ratio. Tan ratio of this 30 degrees angle. This is not the gradient I'm calculating. Just considering the tan ratio just to give you an idea. Tan ratio of 30 degrees is 1 over square root of 3. Tan ratio of 150 degrees, we can't directly find it. So we try to write it with the help of quadrants. The quadrants will this is tan 180 degrees minus 30 degrees. No? This is in the second quadrant. No? Second quadrant tan is negative. Second quadrant tan is negative. There is an even multiple of 90. Tan doesn't change. 30. So minus tan 30 degrees, which is minus 1 over square root of 3. I can see one thing. Move plus 1 over root 3, this is minus 1 over root 3. So when there are two straight line segments, the main idea is there are two straight line segments. In between the two straight line segments, we can see primarily two angles. No, one is an acute angle, one is an obtuse angle. The tan ratio of the acute angle is positive, tan ratio of the obtuse angle is negative. But if you take the magnitude of it, okay, size the tan ratio of both of them are equal. No? Magnitude means what? By the word magnitude, what did I mean? Absolute value of tan 30 degrees equals to the absolute value of tan 150 degrees. We know absolute value of a real number we discussed in real numbers lesson. Modulus functions. And then when we discuss quadratics and polynomials discussions also, we discussed about this. Past papers karaddi talk kara. For 26 batch, modulus functions inequalities karaddi meka aayega ta kara. So this is equals to 1 over root 3 minus 1 over root 3. Both of them, if you take the magnitude, it's 1 over square root of magnitude 1 over square root of 3. Size 1 over root 3. So puta obtuse angle and acute angle in between two straight line segments will have the same magnitude when considering the tan ratio. Same magnitude when considering the tan ratio. Values got the different. Value is plus 1 over root 3 minus 1 over root 3. So main idea we are going to develop a discussion further using this one. Hari? Absolute value means now those who don't know that මේ කතා කරද්දී සමහරව පුදුමයෙන් බය බලන් ඉන්න මොකක්ද යකෝ මේ absolute value. Absolute value of a real number means පුතා, for an example, absolute value of 5 means if you take a straight line segment, a real number line, on the real number line from 0 to that number 5, the length is called as the absolute value. මෙන්න මෙතෙන්ද තියෙන length එක is 5. If it is absolute value of minus 5, what is it? Length of the straight line from 0 to minus 5. Minus 5 ගත්තොත් length of the straight line from 0 to minus 5. Length is 5 පුතා. Distance එක. This distance is 5. Apudha, this is what we call the absolute value. So absolute value of a positive number and absolute value of a negative number, both are going to give you the same magnitude 5. So we defined it further. A definition එක මෙතන දෙන්න යන්නේ නැහැ. So if anyone needs the idea of absolute value, අපේ first few sessions වල recordings YouTube ගන්න නැත්ද කොහෙද ඒක? Okay. After the class drop a message මම මේකට ඕන කරන recording part එක විතරක් එවන්නම් ඔයාලට. කරගෙන නැත්තම් 27 batch, 26 batch, plenty of times we have did calculations using this, so you don't need to request. Right, 26 batch මගේ පන්ති නැති ළමෙක් නම් ඔය ඉන්නේ request කරලා කවන්නේ කරගෙන නැත්තම් මගේ පන්ති උන් 26 batch request කරන්න එපා දෙන්නේ නැහැ. උඹලා දැන් වැඩ කරලා තියෙන්න ඕන. Right, and 27 A level students, since you all are not new, in another few more months ඔයාලා seniors level එක තව මේ චූටි පැටව ටිකක් එනවා. Right, so එතකොට ඔයාලා තව පොඩි නෑ, but let's say ඔයාලා the මේ ලාබාල මේ level batch එකනේ at the moment 27 A levels, 26 දැන් බයසයි. හරි, ඔයාලා if you can't remember the idea of absolute value of a real number, then drop a message to me after the session. I will send the recording of that part. A part එකේ real numbers ටිකේ recordings ටික දාන්න. So now for the moment, just for the time being, understand that absolute value, this modulus brackets return us what puta? Returns the size of the number. Number එකේ size එක තමයි දෙන්නේ. Okay, it gives the size of the number. Right, so both tan ratio of the acute angle and the obtuse angle, absolute values are same. Absolute values are same. Tagala note එකක් දාගන්න. Quickly put a note. Right, write this note. Write this note. Write this note. In between two straight line segments, two non-parallel straight line segments, better to write like that. In between two non-parallel straight line segments, 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 there are two main angles. There are two main angles. There are two main angles. One is an acute angle and the other one is an obtuse angle. One is an acute angle, the other one is an obtuse angle. One is an acute angle and the other one is an obtuse angle. When considering the tan ratio of both the angles, when considering the tan ratio of both the angles, when considering the tan ratio of both the angles, the magnitude of the tan ratio, the magnitude of the tan ratio, the magnitudes of the tan ratio, the magnitudes of the tan ratio are equal, are equal, are equal, are equal. But when considering the values, but considering the tan values, when considering the tan values, but when considering the tan values, tan value of the acute angle is positive. Tan values, put a comma and write, put a comma. Tan value of the acute angle is positive, and the tan value of the obtuse angle is negative, and the tan value of the obtuse angle is negative. Tan value of the obtuse angle is negative. Tan value of the obtuse angle is negative. Okay, no? Okay. Right. Ahangin. Now stop working. Ahangin na puta. Then make a alut wadak. Listen carefully. If I take a pair of straight line segments which are not parallel, it has an acute angle and an obtuse angle in between it. So we know the tan ratio of theta and tan ratio of 180 minus theta, values are different. One is positive, the other one is negative. But when we are considering the magnitude of them are equal. Magnitude of them are equal. The magnitude is actually returning the acute angle tan ratio in a value. If you observe the previous one, tan 30 degrees is 1 over root 3. Tan 150 degrees, which is 180 minus 30, is minus 1 over root 3. But the magnitudes of them is equals to 1 over root 3. Magnitudes if I take the magnitude of it, it's going to be 1 over root 3 only. Basically, so tan ratio of an acute angle equals to modulus value. Here, absolute value of the tan ratio of an acute angle, absolute value of the tan ratio of the obtuse angle, both of them are equals to the tan ratio of the acute angle. May 1 over root 3 whatever the value you get from here, not without the bracket, make a minus. When we are considering the modulus, it gives us the magnitude. That magnitude is same as the tan ratio of the acute angle. That's the observational result. Now listen. Now listen. Now let's say I have a pair of straight line segments like this. On the Cartesian plane. I'll draw it there. So let's have a straight line segment. I'll take it as L1, and I have another straight line segment which are not parallel to both x-axis and y-axis. But these are on the Cartesian plane. I'll take the x-axis like this and y-axis like this. Okay. I'll make this one also an acute angle, just for the discussion purposes. Okay. So if this is theta, this angle is going to be 180 minus theta. Listen now. Now I'm going to do a small derivation. Let's take this angle as alpha. What is alpha? The angle made by L1 straight line segment with the positive side of the x-axis. We'll take this angle as beta. What is it? The angle made by the what? Angle made by L2 straight line segment with the positive side of the x-axis. So if I'm taking the let gradient of L1 and L2 be M1 and M2 respectively. Respectively means පිළිවෙලට. For L1, for line L1, the gradient is M1. The line L2, the gradient is M2 කියලා ගන්නවා. Now, how did we define the gradient of a straight line segment, Puta? Gradient of a straight line segment is given by the tan ratio of the angle made by the straight line segment with the positive side of the x-axis. Then කියන දේවල් සරපට ගාලා ඔළුවේ හිටින්න ඕන. You must have a good memory power, okay? නැත්තම් අමාරුයි. දැන් සාමාන්‍යයෙන් A level whatever the subject stream you take, you have to have a memory power. Amnesia තියෙන උන්ට A level කරන්න බෑනේ. Right? And obviously when it comes to mathematics, little bit of a critical thinking is important. එහෙම කරන්න බැරි කට්ටියට තමයි පුතා අර අනිත් subject streams හදලා තියෙන්නේ. Right? දැන් හිතන්න බෑ මම හිතන්නෙම නෑ. මම කටපාඩම් විතරමයි කරන්නේ. අනුන්ට තමයි ආර්ට්ස් තියෙන්නේ. Right? මට හිතන්න බැරුව නෙමෙයි හැබැයි මට චුට්ටක් කම්මැලි වගේ දිනවා. උන්ට තමයි කොමර්ස් තියෙන්නේ. maths biology tech කරන උන් හිතන්න පුරුදු වෙන්න. හරි? M1. M1 is the gradient of this. How to take it? Tan ratio of the angle made by the L1 straight line segment with the positive side of the x-axis alpha. Tan alpha. What is M2? Simple lemma. What is M2? Tan ratio of the straight line L2 making with the positive side of the x-axis beta. Tan beta. Then අහන් Quick recall. What's the tan A plus B form? Tagal again. Tan first plus num plus tan second divided by 1 minus tan first tan second. මේක ඕනේ ඈද? We need that pattern. ආන්ගේ. Now, if I am doing this seminar 28 batch එකේ ඉන්නවා නම් මම මේක කරන්නේ නැහැ 28 batch එක දාලා. Why I call 27 batch also for this? Because the parts that you need to know in relation to the trigonometry is already completed in the classes. මගේ class එකේ නැති වුණත් අනිත් classes වල පවා කරලා ඇති. කරන්න ඕන මේ වෙලාවට trigonometry මේ පාස් ටික කරලා ඉවරයක් වෙන්න ඕන. හරි? එහෙම කරලා නැත්නම් පාඩුවක්. So that's why I invited 27 batch also for this. So for 26 A level batch students, this is the time we have to start coordinate geometry. Coordinate geometry පටන් ගන්න ඕන වෙලාව මේක තමයි. 27 batch එකට මේක ගොඩක් කලින් මම කරන්නේ because we have to cover the syllabus bit early. Paper series එක යන හින්දා your paper class starting on December no for 27 A level ඒ හින්දා. Right. Now if you take this triangle here, we can see exterior angle is equals to the sum of interior opposite angles. So beta is equals to alpha plus theta. Alpha plus theta. So what I will do is, I will keep theta here, take alpha to the other side. So we will get theta equals to beta minus alpha. Beta minus alpha. Same as tan A plus B form, tan A minus B form එකක් දැනගෙන ඉන්න ඕන. What I'm going to do is, I'm going to consider the tan ratio of both sides. දැන් පුතා ටක් ගාලා online student කෑ ගහලා කියන mic එක unmute කරන්න එපා. කෑ ගහලා කියන ගෙදර ඉඳන් මට මෙහෙට හෙන්න ඕන. උඹලත් කෑ ගහපන්. What's the pattern here? Tan beta කෑ ගහපන් බං minus tan alpha over 1 plus tan beta tan alpha. Right? So what is tan theta now? Of the tan theta is equals to Modulus එක පස්සේ consider කරමුකෝ. What is tan beta? Tan beta is m2 minus m1 over 1 plus m1 times m2. Put a star mark and name it as star. Name it as star. Now listen. If I am considering this 180 minus theta, A kawuda here? Tan 180 minus theta, we know that it's minus tan theta, no? It's in the second quadrant. So we know that minus times tan theta, then it should be equals to minus, what puta? Of this, star wala minus. So minus m2 minus m1 over 1 plus m2 times m1 or m1 times m2. ඔන්න ඔහොම එකක් එනවා. What is this? Tan 180 minus theta. This is equals to minus times m2 minus m1 over 1 plus m1 times m2. මේ මොකක්ද තමයි මේ කියන්නේ? What did we derive here? Observe and see. මේ කවුද? Not the gradients. These are not the gradients. What we derived? Tan ratio of the acute angle and the obtuse angle can be calculated if we know the gradients of the straight lines. Straight lines වල gradient දන්නවා නම් උන් අස්සේ හිර වෙලා ඉන්න angle එක හොයා ගන්න පුළුවන්. Right? No need to have a compass or protractor එකක් තියාගෙන measure කර කර ඉන්න ඕනේ. If you know two straight lines gradients, let's take two straight lines, whatever the result we get, a results වල තියෙන letters වලින් identify the pattern. Let's say this one's gradient is 2, this one's gradient is 3. If I want to calculate this acute angle, then tan theta, this is equals to, then put okay, directly gonna by we have to take the absolute value actually. Alright, so let's say this is a positive one kilo here, m2 minus m1 kilo 3 minus 2 divided by 1 plus 3 times 2. It's right. m2 minus m1 divided by 1 plus n2 times m1. So this is equals to 1 over 3 times 2 is 6, 6 plus 1 is 7, 1 over 7. What is it? Tan ratio of theta. Therefore theta means kawuda? Tan inverse 1 over 7. Tan inverse 1 over 7. In case if we get the value 1 here, simplify karla, let's say you got value 1, then theta is equals to 45 degrees, we can find it. So, මෙච්චර දඟල මොකක්ද ගත්තේ? What did we find? We found the what? We found the tan ratio of the angle. It can be either the acute angle or the obtuse angle. Tan ratio of the angle in between two straight line segments. Tan ratio. We can't directly get the angle. We can get the tan ratio of the angle. How do we get it? If we know the straight line segments, intersecting the straight line segments, if we know the gradients, with the help of the gradients, we can get it. Remember the pattern is easy, because it's tan A minus B form making in me. A minus B over 1 plus A times B. That's the format, no? Same thing. Gradient 1 minus gradient 2 divided by 1 plus gradient 1 times gradient 2. Pattern remembering is very important. Pattern එක ඔළුවේ තියාගන්න ඕන. Now the thing is, remembering two formulas for acute angle and obtuse angle is time consuming. අපි මොකෝ කරන්නේ? We know that absolute values are equal to this, no? එහෙනම් I'm considering the absolute value of tan theta. This is equals to absolute value of tan 180 minus theta. This is equals to absolute value of this. Minus එකේ මෙයාගේ දෙන්නගේ absolute value එක same thing. m2 minus m1 over 1 plus m1 times m2. ඔන්න ඔහොම අරගන්න. We can take like this. So since we are considering an absolute value, puta, remember m2, m1, m1, m2 මාරු කරාට no problem. Why? Even though you get a negative answer, since we are considering the absolute value, the result is going to be a magnitude. Result is going to be a magnitude. Okay. So what did we calculated as a result? The angle between two straight line segments tan ratio එක ගන්න pattern එක. Difference of the gradients divided by 1 plus product of the gradients. Difference of the gradients divided by 1 plus product of the gradients. හරි. දැන් ඉතින් මම කිව්වට තේරුමක් නැහැ. When you are, first of all draw this one and then carefully draw this. Step by step understand and develop it. Step by step understand and develop it. Understand kara kara develop karanna. What do we get here? Me kawuda? This is the tan ratio of the acute angle. Acute angle ke because this one absolute value is giving you the tan ratio of the acute angle. Acute angle between the two straight lines. Between the two straight lines. Not the angle, but the tan ratio of the angles. Tan ratio ke then inverse function dala we can calculate the acute angle. Theory 4. Listen. Below that write a sentence. Theory 4, below that write a sentence. The tan ratio of the acute angle between two straight lines. Theory 4 is tan ratio of the acute angle between two straight lines. There are two straight lines. If the acute angle is theta, we know tan theta is equals to, if the gradients are m1 and m2, what is it? Modulus of m1 minus m2. පිළිවෙල වැඩක් නැහැ. 1 plus m1 times m2. Okay. However, since we are considering the modulus, මොකක්ද වෙන්නේ? size එක තමයි එළියට එන්නේ. We get the size out. Okay.